Well, hello and welcome to this exercise on factors, multiples, and algebra. Again, an iGCSE type question. There are three questions in this video, and each question carries 3 marks. The first one says, prove that 5x plus 1 all squared minus 3x minus 1 all squared is a multiple of 4, okay, for all positive integer values of x. Now, this reminds me of difference of two squares. If we say 5x plus 1 is a and 3x minus 1 is b, we have something like a squared minus b squared is equal to a plus b into a minus b. So now, if rather than 5x plus 1 squared minus 3x plus, minus 3x minus 1 squared, we have 5x plus 1 plus 3x minus 1 as a plus b, and 5x plus 1 minus 3x plus 1, because when you open the brackets, the minus sign will change to plus 1 there. So that's what you got. Now, this bit, the a plus b bit, will give us 8x, because 1 minus 1 is 0, so that gives us 8x. In the a minus b section, we have 2x plus 2. So we end up with 8x into 2x plus 2. If you factorize this, you don't have to do that. But if you factorize 2x plus 2, we end up with 16x into x plus 1. Now, 16 or 8, each of them is a factor of the expression 5x plus 1 squared minus 3x minus 1 squared. And 16 is also a multiple of 4, so it's 8. Therefore, the expression 5x plus 1 all squared minus 3x minus 1 all squared is a multiple of 4. Okay, now next question. And that says the table shows 6 expressions. X is a positive integer. Okay. Then it says, from the table, write an expression whose value is always even. Okay. Now it will always it's always even if a factor of the expression is divisible by 2. The one that comes to mind is this one here, because that's divisible by 2. You can divide 4 by 2, so that's what it requires. And if you wish, you can factorize 3x minus 3, and then that gives us 12 into x minus 1. Now, 12 is a factor of the expression, and 12 is divisible by 2. Therefore, 4 into 3x minus 3 is always even. Now, next one, and it says always a multiple of 3. Now, if one of the factors of the expression is a multiple of 3, then that expression is always a multiple of 3, right? So if one of the factors of the expression is a multiple of 3, that expression is a multiple of 3. So if we don't have 3x minus 6 will give us 3 into x minus 2. So 3x minus 6 is a multiple of 3 because it's got 3 as a factor. Okay, and the third one says, from the table, write an expression which is a factor of 9x squared minus 1. Right, now we can express 9x squared minus 1 as 3x all squared minus 1 squared, because 1 squared is 1. And then we're back to where we started, because this then becomes a question of difference of two squares. So 3x squared minus 1 will give us 3x plus 1 into 3x minus 1. And 3x minus 1 is a factor of 3x squared minus 1. So that is a factor. Okay, now for the third question, which is a little bit more involved, and it says the table shows some expressions. A, B, C, and D represent lengths. 3 and 2 are numbers that have no dimensions. Okay, and then it says um, which expressions represent volumes. Right. For instance, if you measure a line, that's a length. If you measure area, that will be length times length. That's length squared. So the exponent is 2, or the index is 2. And if you measure volume, it will be length times length times length. That's L cubed. So the index is 3, or the exponent is 3. So whenever the exponent is 1, that's length. When the exponent is when the exponent or the index is 2, that represents area. And when the exponent or index is 3, that represents volume. Right. Now for the first one here, now don't forget to multiply for the numerator. And when you multiply numerator, you add, when you multiply two variables, you add the indices. So in this case, a to the power 3 and b to the power 1. Okay. 3 plus 1 will give us 4. So the numerator gives us an index of 4. And when you divide, you subtract the indices. And in this case, we got 3. So if we do 4 minus 3, we get 1. So L to the power 1. So in this case, this expression represents length. Now, for the second expression, c squared into b plus d. Now, b plus d is length, so that becomes L1 if you like, L to the power 1. And because we're multiplying, we should add the indices. So 2 plus 1 will give us 3. So this expression here represents volume. Now in this case here, we got a squared times b cubed. And because we're multiplying, we have to add the indices. So 2 plus 3 is 5. Now that does not represent volume because you've got L5 there. L to the power 5. Now in this case here, we've got a squared times c to the power 1. Now because we're multiplying, we add the indices. So 2 plus 1 is going to give us 3 because c is c to the power 1. Now 2 plus 1 is 3. So this expression represents volume. Now for D3, now there's no argument about this one. Now it's d cubed, d to the power 3. So that in itself is volume. Now in this case here, we've got a cubed d. So a cubed d to the power 1. So the index for the numerator will be 3 plus 1, which is 4. And because we're dividing, the index for the denominator is 1. And because we're dividing, we have to subtract. So 4 minus 1 will give us 3. So this expression represents volume. Now, for this one here, we've got c squared, which is in effect area, L times L, which is area, and d is length. And you cannot mix up area and length. So this is not volume. Now, I hope all that made some sense, and please subscribe. Thank you for watching.